Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the chapter current electricity, and here we are going to solve so many questions based upon the electric power, okay, and the combination of the bulbs also. So let's start the video and let's learn all these questions. So here the first question asked in a NEET 2022 exam. So you can see the question is: two resistors of resistance 100 ohm and 200 ohm are connected in parallel in an electric circuit. The ratio of thermal energy developed in 100 ohm to that in 200 ohm in a given time is how much here? Okay. So remember that here the key word is the power, parallel. Which kind of connection is there? The parallel connection is there. So remember that here for the parallel connection, you know, the heat energy developed is given by power into time, is it? And for the parallel connection, we will use the formula always V square by R into T. Okay. Now from here we can tell one more thing here. The time is constant in a given time and the V is also constant, is it? So here what we can write here, we can write here H is inversely proportional to R. Okay. This is the concept. After that, what will happen that here? If we talk about here the ratio, so R1 is to R2. Now, let's take this is R1, this is R2. How much it is given here? 100 by 200, or we can write here 100 is to 200. You can write 100 by 200 also, and it will become here 1 is to 2. Now, this is a given data. Now, as you know, H inversely proportional to 1 by R, that means we can write here from here, we can write here, hence this H1 by H2 is equal to, from here what we can write, R2 by R1, okay, R2 by R1. You know very well R1 by R2 means 1 by 2, that means R2 by R1, how much is there? 2 by 1. How much is the answer? You can see very well. This is the thermal energy generated or thermal energy developed will be how much here? 2 is to 1. Which option is there? The correct option is here option B, okay. So remember that for the parallel connection we will use V square by R, and for the series connection we will use I square R, okay. And there what will be there? Remember that here for the series connection you know very well P is I square R. Now, so here this P will be directly proportional to R. Now remember that we are going to use in a next question, okay, great. Now the question asked in a JEE 2019, the question is, let's go through it. Two electric bulbs rated at 25 watt 220 volt and 100 watt 220 volt are connected in series across a 220 volt voltage source. If the 25 and 100 watt bulbs draw power P1 and P2 respectively, then which options are correct here? Okay. So remember that here first we have to calculate here the resistance of the bulbs. Now, so if we talk about here for the first bulb, what is the resistance? You know the formula R, P equal to V square by R, that means R equal to V square by P. Okay, so we can write here, see, R means V square by P, R1 means V square by P1. We will use this ratings here, so it will become here what? 220 square by 25. Now, this is the resistance of the first bulb. Similarly, R equal to V square by P, but now for the second bulb, what this will become here again here? 220 square, and how much is given here? This 100 watt is this, na? So 220 square by 100, is it? Now this is okay. After that, what will happen that here? They are connected in what? They are connected in series. So remember that here for series, what I have told you, P equal to I square R. Now, P equal to what is this? I square R. Power I am telling that here. That means P is directly proportional to R. Now, that means what we can write here? Hence, we can write here, students, see, this P1 by P2, we can write here what? R1 by R2 for series connection. R1 by R2, is it? So, when you will take here R1 by R2, what this will become here? 220 square by 25 and 220 square by 100, okay. So, anyhow, this 220 square will cancel out. So, anyhow, let me write here, okay, 220 square by 25 by 220 square by 100, is it? I have written like this. So, Anyhow, what will happen that here, this 220 square and this 220 square is cancelled. So we can write here, see, 1 by 25 into 1 by 100, it will become reverse. That means what is coming here, 100 by 1. Now, that means we can write here, hence P1 by P2 is equal to what here, 4 by 1, or we can tell very well, P1 is a 4 times of P2. Remember that here in series connection, a bulb of lower wattage now will dissipate more power, more energy. Okay, so P1 equal to 4 P2. You can see, you can check the option here. By checking the options and all that, you can see when the P2 is 4, if the P2 is 4, P1 will be how much? 4 into 4, 16. That means only option A is satisfying this condition. Okay, students. So as I have told you, remember that here in series connection, a bulb of lower wattage will dissipate more power, and in parallel connection, a bulb of higher wattage will dissipate more power, as I have discussed in our previous videos. Okay. Now next one we'll see. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value. Okay. Now the percentage of the rated value by which the power would decrease is. Okay. So anyhow, here we are going to use one approximate formula, because whenever this error, increment, decrement is given up to 10%, that error formula we can use. That's not a big problem. So what it is given here, see, the voltage drops by how much here, 2.5%. That means I can write here, see, this delta V by V is given how much here, 2.5% drop, means I write here minus 2.5 by 100. Percentage na per 100, so minus 2.5 by 100. Okay. After that, next one we will use the formula here, see, P equal to V square by R. Now, and from here I will write here the error equation, or we can tell error expression. In a units and measurement chapter, we know that here this error equation is given by delta P by P. Here V square means 2 times delta V by V. Resistance nothing is given, that means no change in the resistance. To be more specific, even you can write P directly proportional to V square. Then you can write delta P by P equal to 2 times delta V by V. Okay. This is the main formula. But remember that here this is valid up to how much percentage? Up to 10%. Otherwise, we have to go by the very general method. That means we can write here what, students, see, delta P by P, and here 2, and delta V by V, how much here? Minus 2.5 by 100, is it? So it will become here minus 5 by 100. Now this is called relative error, or we can tell fractional error in power. Okay, hence percentage error in power. Now percentage error in power is given by delta P by P into 100. Anyhow, what will happen that here, see, minus 5 by 100 into 100. 100 cancels. So what is coming here? Minus 5%. Minus is indicate that anyhow the power will decrease. Which option is correct here? The correct option is here option C. Okay. So I hope so. This is very, very clear to you. Now we'll go to the next one here. This question asked in a NEET 2003, concept important. See, two 220 volt 100 watt bulbs are connected first in series and then in parallel. Okay. Each time the combination is connected to a 220 volt AC supply line here. See, even this all whatever we are learning, that is applicable for the AC also. But okay, whatever voltage is given, that is called the RMS voltage. Okay. Now, the power drawn by the combination in each case respectively how much? That means first in a series and then in a parallel. Okay. So remember that here whenever we are going to see this, so first I will write here series connection here for series. For the series. Okay. For series, the power formula is given by, remember that here PS equal to, for 2 bulbs I am writing PS equal to, this is P1 P2 by P1 plus P2. What is this? P1 P2 by P1 plus P2 for series connection. And when to use this formula? This formula is valid when the rating of the bulb, voltage rating of the bulb and the supply voltage is equal. Always remember that here, P1 P2 by P1 plus P2. But you know very well here, both the bulbs are here, how much here? Both the bulbs are here 100 watts. So I can write here P1 equal to P2 equal to P, how much is given here? 100 watt. Okay, so here if I write here the special case, so right here, if P1 equal to P2, now P1 equal to P2 is equal to P, then for series connection, this PS will become here, you can write P into P by P plus P, it will become here P by 2. Now for 2 bulbs, P by 2, 3 bulbs, P by 3, 4 bulbs, P by 4 and all that. Now, and P how much is given here? 100. So 100 by 2, how much coming here? 100 by 2 means 50 watt. Okay, so in series connection, both these bulbs equivalent will be how much here? 50 watt. Okay, similarly students, if we'll go for the next one, let's take it for parallel. For parallel. So for parallel, what will happen? That remember that here, this PP is given here P1 plus P2. Now for 2 bulbs. 3 bulbs means P1 plus P2 plus P3. 4 bulbs means P1 plus P2 plus P3 plus P4 like this. Now, and if I use here again special condition, this P1 equal to P2 equal to P, then what this will become here? It will become here in parallel means P plus P means 2P. Okay, and each bulb 100, so 2 into 100, how much here? 200 watt. Okay, so you can see very well where is the 50 and 100 is there. You can see here the correct 50 and 200. 50 and 200 is where it is. The correct option is here option D. Okay, but remember that here the rated value, rated voltage and the supply voltage both should be what? Equal. Okay, great. Next one, kindly see here. All these important questions we are solving. So see, JEE 2012 question is here. Kindly see here. The power dissipated in the circuit shown in the figure is 30 watt. No? This is the circuit. The value of R how much here? Okay. So remember that here first we have to draw here the equivalent here. Now let's take here for example, here I have taken here the terminals A and B. Okay. So across point A and B will draw here the equivalent resistance. Now, so what will be the equivalent resistance will be there? Tell me here, students. So you can see very well this R and 5 connected in parallel. Now, so when two resistors are connected in parallel, the formula is R1 R2 by R1 plus R2. Now, very easy. This is the formula here. So when I will use this formula, what this will become? 5 into R. No, 5R by 5 plus R. Very easy. That means here what is given here? This 5R by 5 plus R. This is the resistance. And here how much here? 10 voltage there. Is it? And now according to the question, the power, how much is given here? It is dissipating 30 watt. Okay, now see here please. As, what is the power formula? P equal to V square by R equivalent. No? Now after that, just kindly write here. P how much is given here? 30. No? It is given in the question. V square means here it is given here 10 square. No? 10 square means 100 by R equivalent. How much is this? Kindly see here. 5R by 5 plus R. Okay. Now after that, when we will simplify this, now let me simplify. Just we have to simplify. 5R by 5 plus R is equal to 100 by 30. Cross multiplication I have done. Okay. That means 0 0 cancel. It will become here 10 by 3. Is it? Now do the cross multiplication. 5R into 3 means 15R, and here this 5 I will send here. See, so 5 into 10 50 plus 10R. Correct? Na? 5R into 3 15R. 5 into 10 50 R plus 10 10R. Is it? That means further it will become here. You can see this 10R will come this side. So 15R minus 10R. No? 15R minus 10R is equal to here how much here? 50. Okay. That means now I think so you can see very well. This is given a 5R is equal to 50. Then hence R how much here? R is given here the 10 ohm. Is it? That means this R should be how much here? 10 ohm. Which option is correct here? Anywhere option? Yes, the correct option is here option C. Okay. Great. Now students, next one we are going to see JEE 2024. Question is this now. This kind of circuit diagram is there. So kindly see here. In the following circuit, the battery has an EMF of 2 volt and an internal resistance of 2 by 3 ohm. That is given here. Okay. The power consumption in the entire circuit is how much here? Okay. Now the concept is somewhat reverse compared to previous question. Now the thing arises again. I have taken here, this is terminal A, this is terminal B. Okay. And here we have to find out here the equivalent first here. Now, so this is A, this is B, Now this is 2 volt, this is 2 by 3 ohm. Now here we have to apply little bit the combination of the resistors here. Now, so remember that here one thing here. Here you can see very well, students, here. This is the points. Now directly shorted. So let's take here, if I give the point here M, this is also M. Here also you can see shorted here. Now this is N, this is N. Okay. And after that, let's take this point I have written O. So you can see very well, this 2 ohm connected between M and O. This 2 ohm is connected between M and O. That means this 2 ohm and 2 ohm connected in a parallel. How much? When 2 and 2 connected in parallel, it will be 1 ohm. Okay. Similarly, this 2 ohm connected between N and O, this 2 ohm connected between N and O. So this and this also in parallel. So how much here? This will also come 1 ohm. So this is 1 ohm, this is 1 ohm, and that is what? That is connected in series. Now, okay, just for your sake, I am just drawing here. See, like this I am drawing here. Now, so that you can see actually the what is going on here. See here, this is 2 ohm, this is 1 ohm, this is 1 ohm, this is 2 ohm, and like this is there. Okay, and if you wish, I can write here. See, this is M, this is N, and this is O. Is it? Now you can see very well. This 1 ohm in series, 2 ohm, then 2 ohm, 2 ohm, 2 ohm in parallel. So 2 ohm, 2 ohm, 2 ohm in parallel, 2 by 3. How much will come here? It will come here 2 by 3, 2 by 3 ohm. Okay, and here you can see very well, this is 2 volt, and here anyhow the resistance is connected 2 by 3 ohm, like this is there. Okay, and now what will happen that here? Now the circuit is very well simplified. This is plus, this is minus, no? And all these things will happen. So what they are asking here, the power consumption in the entire circuit. So remember that here, now this 2 by 3 and 2 by 3 connected in series. Why? Because if current I will go here, here current I, and here also current I will come. Okay, that means in this circuit I can write here voltage how much here? 2 volt. Is it? And after that resistance R equivalent, how much is this? What we have got here? 2 by 3, 2 by 3 in series, how much here? 4 by 3 ohm. Is it? So 2 volt, 2 by 3, 2 by 3, 4 by 3 ohm. Now after that we have to write here the power. So power is given here anyhow, very easy. V square by R equivalent. Is it? So V square is how much here? 4. V square means 2 square means 4, and R equivalent how much here? 4 by 3. Is it? So anyhow what will happen that here? You can see very well. This will become here 4 into 4 by 3 means it will become what? 3 by 4. 4 cancel. That means how much is coming here? You can see very well the 3 watt. Is it? That means this circuit is going to consume how much power? 3 watt power. Here I can write here 3. Is it? So can you see here? Very well. Is it? Correct on the calculations. Now next one, let's see. Okay. So JEE 2023 question is this. See, the H amount of thermal energy is developed by a resistor in 10 seconds when a current of 4 ampere is passed through it. If the current is increased to 16 ampere, the thermal energy developed by the resistor in 10 seconds will be how much here? Okay. So here one thing you have to remember that here, initially how much time is there? 10 seconds. After that also how much time is given? 10 seconds. That means what is this? The time is constant. Is it? Question is there in front of you. After that, even they are talking about the resistor also. Okay, so before also they are talking about a resistor, and again they are telling resistor, no change in resistors and all that. That means what is this? The R is also constant. Okay. Now the next one we have to use the formula S H, now Joule's law of heating, H equal to I square RT. So R is constant, T is constant anyhow. That means what we can write here, hence H is directly proportional to I square. H is what? Directly proportional to I square. Okay, that means I can write here, see this H2 by H1 is equal to what we can write here, I2 by I1 whole square. Is it? Now the new current how much here? 16 ampere. So I can write here 16. And the initial current is how much here? 4. So this is here 4 by square. Again I am telling, this is the I2, this is the I1. Okay, and after that what this will come here? See, this H2 by H1 is equal to what this will come here? 16 by 4 means 4, 4 square means 16. So hence I can write here H2 equal to 16 H1. Now, and initial heat how much is given here? H. Is it? That means I can write here H2 equal to 16H. No? Very easy. Not that much complex question. So correct option is here. Option B is the answer. No? Can you see here this thing? is it? JEE 2023, recently only they have asked it, is it? Next one question came in NEET 2006 question, important question, that's why only I have taken here. Power dissipated across the 8 ohm resistor, here it is, 8 ohm resistor in the circuit shown here is 2 watt. The power dissipated in watt units across the 3 ohm resistor is how much here? Okay, so let's simplify this here. So here, students, you can see here, this 8 ohm resistor is here, no? And here how much power dissipation is there? The 2 watt is this. How much is given? 2 watt. No? So let's see here. Let's take current is coming I here. No? This current I is here. No? First I will solve in a very general method. So let's take here current is going how much here? I1 current is going. Is it? How much current is going? I1 this side. And let's take I2 will go this side. Even you can use a current divider theorem also. No? But first let's see all this here. So what will happen that here? The power developed across the 8 ohm resistor, how much is given here? 2 watt, is it? That means I can write here, power means I square R. So I1 square into R means 8 is 2, correct? Correct? That means I can write here, see here, this I1 square is equal to 2 by 8 and that means 1 by 4. So hence I1 is coming here 1 by 2 ampere. How much current is going? I1 1 by 2 ampere current is going. Okay. Now next step, if I write here how much voltage, now because this is connected in a parallel, so let's take this voltage is V, is it? Voltage is V. That means I can write here, see here, this voltage V is given here from the Ohm's law, I1 into R, is it? So I1 is 1 by 2, resistance is 8. So 1 by 2 into 8, how much coming here? This is coming here, the 4 volt. How much coming here? 4 volt, is it? Next one after that. This is up to this, okay. So now after that, if I talk about here this current I2, okay. I think so this question can be solved directly by the current divider theorem also, okay. Okay, see here, I2 will be how much here? I2 will come here. How? Because see this is a V, whatever voltage here, some voltage will be here also, and here 1 and 3 in a series. So 3 plus 1 means 4. V how much is coming here? 4 volt. That means 4 by 4. How much current is coming here? 1 ampere current is coming, is it? But the problem will arise with the current divider theorem. This I value we don't know. That's why the exact value we can't calculate here, okay? Now after that, here, what they are asking here? They are asking here the in a 3 ohm resistor. So in a 3 ohm resistor, how much it will develop here? I can write here I2 square into 3, okay. So I2 square means 1 square into 3, that means see, across this, no? Across, not across this actually, across means a voltage. Power we are seeing, na? So how much power will dissipate in this here? 1 square into 3 means 3 watt here, okay. So which option is correct here? The correct option is here, you can see very well, option A is the correct answer. Na? So this kind of question is very common, that's why we have taken here, NEET 2006 question, okay. Next one, let's see here. JEE 2000, JEE, not JEET, no? JEE 2024 question. So let's go through this question also. The question is, when a potential difference V is applied across a wire, a resistance of R, it dissipates energy at a rate W. Energy at a rate W. Okay. If the wire is cut into 2 holes and these holes are connected mutually parallel across the same supply, the energy dissipation rate will become how much here? So rate of energy dissipation is called power also. No? Rate of energy dissipation is called power also. Okay. So first we'll talk about here the initial situation. So the voltage is V, no? Rate of energy dissipation is W, and how much resistance is this? The resistance is R. Okay. That means we can write here, I can write here, see, the rate of energy dissipation, that means power. This is given by W equal to V square by R. Is it? Because P equal to V square by R. No? What is P? Power. Here W is the power, rate of energy dissipation. Okay. This is given here. After that, what is happening that here? They are talking about your series, parallel, drama and all that. No? So first, what is this? First, it is cut into 2 holes. So you think here, students, this is the one wire. No? This wire is this. No? And you know the resistance is directly proportional to length. Is it? Resistance is what? Directly proportional to length. So what will happen that here? If this wire you will cut into 2 parts. So total resistance is R. This will become R by 2. This will become R by 2. And after that what is happening that here, both these parts we are connected in a parallel. Both these parts we are connecting in a parallel, like this here, we have connected in a parallel here, okay. So when we will connect here in a parallel, remember that here, so now what will happen that here, this r by 2 and this r by 2 connected in a parallel, let's take here across point AB, okay, parallel. So now here what will be the equivalent here, if I write here the equivalent, it will become here r by 2 in a parallel means I can write here r by 2 it will become here how much here, r by 4, okay. Now after that, if I write here the new rate of energy dissipation, that means power is given by V square by R by 4, R by 4. So what this will become here, it will become here 4 times V square by R, and you know very well what is V square by R, V square by R is W, is it? That means hence I can write here W dash is equal to 4W. W dash how much here, this W dash is here students 4W. Remember that here R, when wire will be cut into two parts, it will become R by 2, and when we are connecting in a parallel, it will become R by 4. Very easy, okay. Now the NEET 2024 question is there. This question is what's here, two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively, okay. Now those two are first connected in series and then in parallel to a fixed power source, power supply. The ratio of power outputs of these two cases is how much, okay. So remember that here, first thing, when they are talking about the ratings and all that, okay. So remember that here P is P equal to V square by R, so what is this, P equal to V square by R, okay. And we can write here, see, P inversely proportional to R. Whenever any kind of rating is given, we have to go like this, this one here, this is important. So if I write here, for example, PA by PB will become what here, RB by RA, okay. Now what is the power rating is given for the heater A, 1 kilowatt, for the heater 2, 2 kilowatt, so heater A means kilowatt will cancel, so 1 by 2 equal to what will become here, RB by RA, okay. That means I can write here, see, RB equal to 2RA. This is this RB equal to 2RA, is it? The first step is done. After that, what will happen that here, when they are connected in series, okay. So for series, what will happen that here, this RS will become here RA plus RB, okay. So RA plus RB, what will become here, see, RB equal to 2RA, this RB how much here, 2RA, so RA plus 2RA, it will become here 3RA, so RS will become here 3RA, this thing is done here, RS will become here how much here, 3RA, RB value I have put here 2RA, some mistake happened, see, that's why I was thinking RA equal to 2RB actually, here mistake is happened, see, this RA is equal to 2RB, mistake happened here, cross multiplication. So RA equal to, when you will put here the RA, you are putting here the 2RB, is it? So 2RB plus RB, it will become here, RS is 3RB. Now, okay, RS equal to 3RB. Hence, if I write here the power in series, it will become here what? V square by RS, and it will become here what? It will become here V square by 3RB, okay. We will make it here equation 1. PS how much here? V square by 3RB, okay. Now after that, when we will go for the parallel, in parallel what will happen that here, if I write here RP means we can write here, see here, RA into RB, parallel connection by RA plus RB, okay. Now RA into RB by RA plus RB. RA how much is given? 2RB. So when you will put here RA 2RB, it will become 2RB square. 2RB plus RB, 3RB. Anyhow, RB cancel. So it will become here RP equal to 2 by 3RB. Is it? Now next one. Hence, if I write here the power in parallel connection, again V square by RP. So kindly put here the value of RP, it will become here RP, when you will put 2 by 3RB, 3 will go up, so 3V square by 2RB, is it? This is the equation 2, okay. So this one we have got here. Now what we need here the ratio, okay. So ratio means, let me write here, So if I write here PS by PP is become here what V square by 3RB, V square by 3RB into this one, reciprocate it, 3 square by 2RB, is it? So many things will cancel out. What are things will cancel out? V square cancel, RB cancel. So this is 2 and 3 into 3, 9, 2 by 9. Any option is where? Correct option is here, option B. Okay students, so I think so this question is also very clear to you. Now we are going to move for the last question. The question is here, by what percentage will the illumination of the lamp decrease if the current drops by 20%? Okay, so let me see here. Let's take the initial current is I1 is how much here? I. Initial current how much here? I1 is I. Okay, and the power how much is this here? The power is given here I1 square R. Okay, I1 square R, or you can write here I square R, no problem. No? This is the one thing. Next one, what will happen that here? Again, I2, new current how much here? Drops by how much here? 20% drop. So when it will drop by 20%, I can write here I minus 20%. That means 20 by 100. Okay, very basic will go here. 20 by 100 into I. That means I minus I by 5. So it will become here what? It will become here 4 by 5 I. How much coming here? 4 by 5 I. 20% drop means 80% will be left. That is the basic thing. Okay. Now after that, if we talk about here the power, this is power P1. New power, let's take here P2. P2 how much here? It is given here I2 square R. So I2 how much here? You can write here 4 by 5. I means I can write here 16 by 25 I square R. No? 4 square means 16, 5 square means 25. So 16 by 5 I square. And what is I square? I square is the P1, is it? That means I can write here P2 equal to 16 by 25 P1, is it? 16 by 25 P1. Now again, what they are asking here? They are asking here the illumination. Remember that here illumination or brightness and all is directly proportional to power. Okay, so we can write here, see, percentage change in power. Now, if positive means increase, negative means decrease, very simple. So percentage change in power means given by P2 minus P1 by P1 into 100. So we can write here, see, P2 by P1 minus 1 into 100. Okay, so P2 by P1 will become what here? If I write here the P2 by P1, P2 by P1, P2 by P1 will become here anyhow 16 by 25. So see here, 16 by 25 minus 1 into 100, is it? So 16 by 25 minus 1 into 100, is it? Now after that, what this will become here? Kindly simplify this. So we can write here, it will become here 16 minus 25 and 100 by 25. Now we have taken here the LCM. I think so step you are getting very well, 25 into 100. So 16 minus 25, how much it will come here? We can tell here 459 minus 9 into 4 and minus 9 into 4, how much here? 9 into 4, 36. And minus 36% means what will happen that here? This the illumination will decrease. No? So when the current will decrease, illumination will also decrease. How much here? 36%. So students, I hope so all these questions based upon the power you have understood very well. Keep studying, keep growing.